The ground beneath our feet seems solid, but, the Earth is always moving. Sometimes it moves a lot in a short time. We call these events earthquake spikes. They are happening more frequently, making scientists and people nervous. What are these spikes? Are they random, or do they warn us of something bigger? These questions are important because earthquakes can be dangerous. They can damage buildings and hurt people. Scientists are working hard to understand earthquake spikes. They want to know if the spikes can tell us about bigger earthquakes in the future. Knowing more about earthquakes helps us prepare. We can make buildings stronger and have plans to stay safe. In this essay, we will explore the world of earthquake spikes and learn what they mean for us. The Earth's surface is not one big piece. It is made up of giant puzzle pieces called tectonic plates. These plates always move, bumping and grinding against each other. Most earthquakes happen at the edges of these plates. They are called fault lines. Sometimes the plates move smoothly, other times they get stuck. Pressure builds up where they are stuck. When the pressure becomes too much, the plates slip. This sudden release of energy causes the ground to shake. This is an earthquake. Earthquake spikes are simply an increase in the number of earthquakes in a specific area over a short period. There are several reasons why these spikes might occur. Earthquakes are a natural process. Sometimes we see more earthquakes than usual, just like we sometimes have more rainy days than sunny days. If the plates start moving faster or in a different direction, it can cause more earthquakes. Volcanoes and earthquakes are often linked. When magma moves underground, it can push on the surrounding rocks, causing them to break and trigger earthquakes. Sometimes movement along a fault line can trigger more movement in other parts of the same fault, or even on nearby faults, leading to a spike in earthquakes. Scientists use special tools to keep an eye on the Earth's movements. These tools are very sensitive and can detect even the slightest tremors. By studying the data from these tools, scientists can learn more about earthquakes and what causes them. These stations are like listening posts for earthquakes. They have sensors buried in the ground that can feel even tiny vibrations. These vibrations are recorded on a seismograph. The information from seismographs all over the world is collected and analyzed by scientists. They look for patterns in the frequency, size, and location of earthquakes to understand how the Earth's plates are moving and where stresses are building up. Satellites in space can also help us track the Earth's movements. They use radar to measure tiny changes in the height of the ground. These changes can tell us if magma is moving underground or if fault lines are shifting. By using these methods, scientists can keep a close watch on earthquake activity around the world. This helps us understand why earthquake spikes occur and what they might mean. One of the big questions scientists are trying to answer is whether earthquake spikes can help us predict larger, more destructive earthquakes, often called megaquakes. While spikes can be a sign of increased activity and stress along fault lines, they don't always mean a megaquake is imminent. Earthquakes are complex events, and many factors influence their size and timing. While a spike in smaller earthquakes might precede a larger one, it's also possible that the spike will die down without any major event. Predicting earthquakes with certainty remains a significant challenge for scientists. However, even though we can't predict earthquakes precisely, the information gathered from monitoring earthquake spikes is incredibly valuable. It helps scientists understand spikes can indicate areas where stress is building up along fault lines, potentially increasing the risk of a larger earthquake in the future. By studying how fault lines behave during earthquake spikes, scientists can learn more about their potential to generate larger earthquakes. While not a prediction tool, data from earthquake spikes can improve early warning systems, giving people crucial seconds to take cover before the shaking from a larger earthquake reaches them. The beautiful Greek island of Santorini is a stark reminder of the immense power of earthquakes and volcanoes. In February 2025, the island experienced a series of earthquakes, with the largest measuring a significant 5.2 on the Richter scale. This main shock was followed by over 200 aftershocks, causing concern among residents and scientists alike. This dramatic increase in seismic activity, a classic example of an earthquake spike, is attributed to the complex geological activity in the region. Santorini sits within a volcanic caldera, a large crater formed by a massive volcanic eruption in the distant past. The island lies near the boundary of the African and Eurasian tectonic plates, making it a hotbed for earthquakes and volcanic unrest. The recent earthquake spike in Santorini is thought to be related to the movement of magma beneath the nearby submarine volcano, Colombo. The movement of this molten rock puts pressure on the surrounding rocks, triggering earthquakes along the nearby Anidros Fault. This intricate interplay of volcanoes, fault lines, and tectonic plate movement makes Santorini a natural laboratory for studying earthquake spikes. The 2025 Santorini earthquakes, while disruptive, serve as a reminder of the importance of understanding and monitoring earthquake-prone regions. By studying these events, scientists can refine their models and improve their ability to assess risk and enhance preparedness strategies. Section 6. Rumbles on Mount Adams, another example of seismic activity. Across the world from Santorini, in the Cascade Range of Washington State, USA, Mount Adams, a towering stratovolcano, experienced an unusual surge in earthquake activity in late 2024. While Mount Adams typically experiences only one earthquake every 2 to 3 years, it recorded 6 earthquakes in a single month, the highest monthly total since 1982. Although this increase in seismic activity sparked concern, it's important to note that Mount Adams is not currently showing signs of an imminent eruption. The USGS, or United States Geological Survey, classifies the volcano's alert level as normal with an aviation color code of green, indicating that the volcano is not exhibiting any unusual activity that would suggest an eruption is likely. However, the unusual spike in earthquakes at Mount Adams prompted the USGS to deploy additional monitoring equipment to better understand the situation. This proactive approach highlights the importance of continuous monitoring and research in earthquake and volcano-prone regions. By gathering more data, scientists can better assess the potential risks and improve our understanding of these complex geological processes. The Mount Adams earthquake spike, while potentially unsettling, serves as a valuable opportunity for scientists to gather more data and improve our understanding of the dynamics of volcanoes and earthquakes. This information is crucial for enhancing volcanic hazard assessments and ensuring the safety of communities living near these awe-inspiring geological giants. Section 7. The Future of Earthquake Prediction, Embracing Uncertainty. Despite significant advances in technology and our understanding of the Earth, accurately predicting earthquakes remains an elusive goal. Earthquake spikes, while potentially valuable indicators of increased seismic activity, do not offer a foolproof method for predicting when and where the next big one will strike. However, this uncertainty doesn't mean we are helpless. Instead of focusing solely on prediction, the focus is shifting towards improved monitoring networks. Expanding and enhancing seismic monitoring networks worldwide is crucial for gathering more data and improving our understanding of earthquake behavior. Advanced forecasting models. Scientists are constantly developing and refining computer models that incorporate a wide range of factors to better forecast earthquake probabilities and potential impacts. Enhanced building codes. Constructing buildings and infrastructure that can withstand the forces of earthquakes is essential for minimizing damage and saving lives. Public education and preparedness. Educating the public about earthquake hazards and promoting preparedness measures, such as developing emergency plans and securing heavy objects, is crucial for building community resilience. Section 8. Living with an Unpredictable Earth, the Importance of Preparedness. While we may never be able to predict earthquakes with absolute certainty, we can learn to live with the Earth's unpredictable nature by embracing preparedness. By taking proactive steps to mitigate the potential impacts of earthquakes, we can create safer and more resilient communities. Here are some essential steps individuals and communities can take to prepare for earthquakes. Develop an emergency plan. Create a family or workplace emergency plan that includes evacuation routes, designated meeting places, and contact information for family members and emergency services. Secure your surroundings. Secure heavy objects that could fall and cause injury during an earthquake, such as bookshelves, mirrors, and light fixtures. Assemble an emergency kit. Prepare an emergency kit containing essential supplies including water, non-perishable food, a first aid kit, a flashlight, a battery-powered radio, and extra batteries. Learn first aid and CPR. Knowing basic first aid and CPR can be life-saving in an emergency situation. Participate in drills. Regularly practice earthquake drills at home, work, and school to ensure everyone knows what to do during an earthquake. Section 9. Conclusion. The unfolding story of earthquakes. The earth beneath our feet is constantly moving and changing, and earthquakes are a natural part of this dynamic process. While the occurrence of earthquake spikes can be unsettling, they also offer valuable insights into the inner workings of our planet. By studying these events and investing in research, monitoring, and preparedness, we can strive to live in greater harmony with the Earth's rhythms and minimize the risks associated with these powerful natural phenomena. The story of earthquakes is still unfolding, and through scientific inquiry, technological innovation, and collective action, we can create a safer and more resilient future for generations to come.